Here's one for you. You're a scientist and you've got an amazing idea. You think it is absolutely golden. You're ready to run your experiment. You get your results back. They prove you wrong. Not only that, another scientist has done an experiment and they prove you wrong even more. What do you do? In 1949 on BBC Radio, the scientist from Cambridge, Fred Hoyle, came up with the term the Big Bang to describe the inflationary theory of the beginning of the universe. The only problem, Hoyle didn't believe in the Big Bang. He meant it in a very dismissive way. He wasn't convinced about the theory's validity, but he's forever now known as the person who gave it its most famous name. Now, Fred Hoyle was an incredibly clever man. He contributed massively to the development of radar technology. He came up with a fantastic theory about how stars can make carbon, founded the Institute of Astronomy, and he also, on top of all this, found the time to write a number of science fiction novels. But the Big Bang theory describing the beginning of the universe is correct according to all our observational evidence, and that's not the case for Hoyle's own steady state theory. How can someone so clever pick the wrong theory? Now, Hoyle wasn't the first, and he'll definitely not be the last, to be a very smart scientist who clung to the wrong theory simply because they refused to believe the evidence. In 1543, astronomer Nicholas Copernicus developed a model for the universe that placed the Earth in orbit around the Sun, replacing the previous Earth-centered universe. And it wasn't though until 1610 when, with his newly developed telescope, Galileo observed moons orbiting around Jupiter, that this idea of a sun-centered or heliocentric model began to gain any kind of traction. In medicine, the idea of germs transmitting diseases from person to person had been proposed in India by the physician Shushruta, and also in the medieval Islamic world by the polymath Ibn Sina. But in Western Europe, medical practitioners believed that it was caused by miasma, dirty air, and refused to change their ideas. It wasn't until the 18th and 19th centuries where experiments by Louis Pasteur and Robert Koch provided evidence that microorganisms could spread and multiply and could be a vector for disease transmission. In chemistry, in the 1600s, chemists believed that in order for a fuel to burn, it had to contain a substance called phlogiston, which was used up, and what was left behind in the ash was anything that wasn't phlogiston. And this would explain their evidence that when you burned a substance and measured the mass before and after, the mass appeared to drop down. However, in 1772, Antoine Lavoisier managed to burn phosphorus in a sealed container and proved that the mass of the substance actually increased, not decreased, once it had finished burning, and eventually oxygen was discovered to be the source of that extra mass. However, even in the face of all this evidence, chemists like Pierre Macquer decided that they had to rework the phlogiston theory to account for this new evidence because they believed in it so much. What we see here is scientists getting attached to a theory so much that they ignore the principles of science, which is that evidence is what informs theory. Eventually, the evidence becomes overwhelming and a new idea starts to take place. Now, these dramatic shifts in scientific knowledge are described by the philosopher Thomas Kuhn in his book, The Structure of Scientific Revolutions, as paradigm shift. These are fundamental changes in our understanding of basic concepts. The Earth is at the center of the universe one moment, but eventually new evidence comes in and all of a sudden it's the sun. The new evidence presented completely undermines the existing paradigm, so much so that scientists are forced to change their minds and adopt a new idea. And this is contrary to the way in which we're taught that science works. We're kind of taught that science is layered, that our basic understanding is built upon like building a house. You start with basic knowledge that's discovered, and then on top of that, new evidence starts to refine the idea a little bit closer and start to add extra details and things like that. The reality is quite different. Other than adding pretty little details to your nice new house, you're actually blowing it up and replacing it with something entirely new. It's a nicer, more modern house that meets your modern needs and requirements. And in science, that would be the new evidence that's collected. So why is it then that some scientists can just never accept the new ideas? Why can they never adopt this paradigm shift? Imagine you spent your entire life supporting a sports team and they're really successful. They've won a bunch of trophies and you're really proud to support that team. You feel very emotionally attached to it. But then one day someone turns around and says, no, your team never won anything. Actually, that team doesn't exist. All those trophies are actually won by this team over here. You're going to feel very confused and kind of upset. You're going to feel hoodwinked. You're going to feel like you believe something that wasn't true. And nobody likes to feel like that. But more and more evidence is mounting up. You ask other people and they tell you exactly the same thing. No, this team won it. Your team, they're not real. So eventually you're left with two choices. You can accept the new evidence. Maybe support the new team that you thought was yours and get on with your life. Or B, you can reject the evidence and you can completely pretend, live in your dream world, that your old team still exists and they're the champions of everything. The reality is most people would probably choose A, and in this case we can say a paradigm shift has occurred. Some people stay with choice B, The emotions that you built up while supporting that team, by the way, the team here, that's an analogy for the scientific theory that was disproven. The emotions built up in supporting that team have now become an emotional investment. If you abandon that team, even though you know realistically that they didn't exist, you're going to feel that that effort, that investment of emotion was wasted. Sometimes people really hate the idea that their emotional investment was wasted, and so they'll cling to the old idea just to maintain a semblance that it wasn't a complete waste of time. And this has happened to scientists all throughout history, all throughout our new discoveries, because at the end of the day, scientists are humans, and humans have all kinds of flaws. The processes in science, the methods in science, they have to follow certain rules. And if you want to know more about what some of those rules are, then there's a video out there you might be interested in.